will cover the handout, mixing it up, and this will be the lesson for Wednesday, October 28th, or Thursday, October 29th, which is my birthday tomorrow. Yeah.
Happy birthday.
Thank you. But not yet, not yet. You have to tell me tomorrow. Okay. So we're going to be working on solving some problems that can be solved by using systems of equations. Sometimes the problems will have two equations. Other times they will have three equations. Three unknowns or two unknowns. So depending on the number of variables that we have to find, we will need that number of equations. So before we get to that, we're going to do a little warm-up or review on how to calculate certain things. After that, we're going to get to the problems. I'm going to do the first two with you, maybe the first three, and then you will be doing the rest on your own. All right? Let's go ahead and get started. And for the first one, we're going to compute the answers to each of the following mixture problems. So who would like to read first? Okay, Andrea, go ahead. Read the first problem.
Florence took a road trip to the beach, which was several hundred miles away. As she left, she had to drive 36 miles per hour through the city for about half an hour. Once she hit the highway, she drove 68 miles per hour for 3.5 to 3.5 hours. Then, as she approached the beach, the traffic was so heavy she could only go 20 miles per hour for the last 30 minutes.
Okay. So we have, let's see if we can answer the first question. How many hours was Florence on the road? Say that again? 4 hours and 30 minutes. Very good. And how do you calculate that? Okay, so 0.5.
3.5 hours.
Uh-huh.
And plus, she went 30 minutes.
30 minutes, which is 0.5, right? Very good. So 4.5, or we may say 4.5 hours. Or we could say 4 hours and 30 minutes. Same thing. Now, let's see. How many miles did Florence travel? Miles, yeah. That might not be too easy to find at first sight. But let's see it, but we can figure it out, right? So, what is the formula for speed?
Distance divided by velocity.
By time. So I'm going to show you an easy way to remember. Who drives here, legally or illegally? Okay. Or you have been behind the wheel at some point. Maybe you are allowed to park the car. Maybe.
Illegally.
Yeah. So we're not going to judge anyone. So what are the units that you see on the speedometer? It said something like miles per hour. So what that means is actually miles divided by hours. So that we could use that as a reference for the measure for the formula of speed. Distance, which is miles, sometimes it's in kilometers, divided by the time. Distance divided by the time. So if we want to find, the question here is asking us how many miles, so it's asking us about the distance, right? The total distance. So once you have this formula, S equals D over T, we could easily solve for D, right? Because what is T doing to D? Dividing, right? So if we move T to the other side, what is it going to be doing? Multiplying. So if we want to find what the distance is for each interval, we could multiply the speed times the time. So let's do that. So we'll start with the city. Through the city, it was 36 miles, so that will be 36 times the amount of time, and that was half hour, so we will use 0.5. Next, we need the highway. She drove 68 miles per hour. That is our speed multiplied by the time, and that was 3.5. And lastly, we have that she drove at 20 miles per hour because the traffic was heavy for 30 minutes, so that's 0.5. So, by the way, I forgot to ask you to get a calculator. So, if you haven't, I'm going to go ahead and pause the video. Please get a calculator. So please, now that you have your calculator, go ahead and enter that. You can enter the whole thing at once. And I will like, Laisha, tell me what you got.
266.
266. What will be our units here? We're talking about, oh, well, it's on the question, right? The total distance. So 266 miles. All right, very good. Now, over the course of the trip, what was Florence's average speed? Now, again, the formula for speed is going to be distance divided by time. But now here we're talking about three different speeds, three different times, three different distance measurements. So what we're going to do is add those three. But before we do that, actually no, we're not going to add those three. I'm so sorry. We're going to use the total distance that she traveled. And we're going to divide it by the total time that she spent on the road. So what was the total distance? 266 miles. And what was the total time? 4.5, right? Or let's go ahead and use 4.5. So if you guys could please divide that. Catherine, what do you got?
59.11
Okay. So let's just say 59.11. That would be okay. Or does the problem say round? Yeah. So okay, I get your reasoning. So you say 59. What will be the units, guys?
miles per hour.
Miles per hour, right? Miles divided by hour, so we could say 59 miles per hour. All right. Let's go to the next one, and that is B. When you buy hydrogen peroxide, it is really a solution diluted with water. One bottle comes in a 2% solution, and another comes in 5% strength. So we have two different bottles. Suppose that you mix. So let's see, one comes in at 2%, one comes in 5%. So hydrogen peroxide is actually water mixed with pure hydrogen peroxide. Like you will never get 100% hydrogen peroxide unless you work a lot, right? And in that case, you'll probably get hurt if you don't use the proper equipment. So whatever you buy at the store is diluted with water. So the first bottle, the one that is 2%, it says here that it is 40. It has 40 milliliters, or at least that's what we're going to mix. The second solution, it has 5% hydrogen peroxide. We're going to mix 80 milliliters. So let's see if we were to mix those two. So we have 40 and 80. So if we were to mix those two, how many milliliters of the mixture is actually pure hydrogen peroxide? So the first solution it contains 40 milliliters. What is the percentage of hydrogen peroxide? 2. If we turn that into a decimal, what would it be? 0.2 is actually 20%. So, 0.02. Now let's look at the second solution, and the total amount of liquid is 80 milliliters, but the amount of hydrogen peroxide as a percentage is what? Very good. All right, so I want you guys to please do that on your calculator. And I would like for Javier to give me the answer.
48.
48.
Yeah. 4.8.
Yeah,
4.8. Okay. So what will be the units, guys? Milliliters. So remember the question, how many milliliters? All right, next question, what percent of this mixture is hydrogen peroxide? So to get the percent that is actually pure hydrogen peroxide, we're going to consider the amount of hydrogen peroxide oh, it's so long. 4.8 milliliters. And we're going to divide that by the total amount of liquid, considering the water and the hydrogen peroxide. So what was the total amount of liquid, guys? 120, right? We didn't really calculate that, but we know that if we add 40 plus 80, we will get 120. Okay, so if you guys could divide that. Yes, Michael? You got it? What is it? 0.04. And as a percentage, what would that be? 4%. So to go from a decimal to a percentage, you need to multiply by 100. Okay, let's look at the next problem. Who would like to read it? John? Okay, Javier, thank you. Go ahead.
Donna always gets really high grades on tests and quizzes, 95 every time, but she only does homework half the time, so her homework grade is 850.
I know some people like that.
Donna's teacher has a policy where tests and quizzes make up only 30% of students' grades and homework makes up the other 70%. Under this system, what would Donna's class grade be?
Okay, so let's see, and this is actually how we grade you. So her grade on tests and quizzes is currently a 95. What percent of her grade will that be? 30, right? Right here, 30. So as a decimal, what would that be? 0.3 or 0.30, same thing. So we're going to add her current grade for homework, which is a 50. And what is the percentage for homework? 70. As a decimal, what would that be? 0.7. Okay, so I want you guys to calculate that, please. What do you get, Victoria? About 63.5. Yeah. Maybe you forgot one decimal. So will Donna pass the class for that teacher? No, right? She will definitely fail. Now let's see what will happen with a different grading policy. So Jasmine, read the question.
A teacher down the hall uses a different policy where tests and quizzes are 60% of the grade and homework is only 40%. What would Donna's grade be if she had this teacher?
Okay, let's see. So her current grade for tests and quizzes is a 95. Now we're saying the percentage is 60, so 0.6. Her current grade for homework is a 50, and that is worth 40%, which is 0.4. Okay, Isaac, what do you got? 77. So will Donna pass the class with this teacher? Yeah, she will pass, right? All right. So raise your hand if you prefer to be with teacher number 1. Teacher number 2? Okay. Now let's see if you remember my grading policy. What are my percentages? For classwork and homework. What is the percentage there?
50.
50, yes. What about tests, quizzes,
10.
and projects?
40.
40. This is the one that you need to be careful, right? You need to be very careful. You can't have zeros there. And then what is the remaining 10%?
The checkups.
The final exam or the 6 weeks exam. If you add those percentages, you get 100%, right?
Where does that binder go in that?
The binder goes here. I thought about putting it in here, but I don't know.
How many people fail that?
A lot of people will fail if I do that. All right, so let's check on time. Let me do at least one of the problems or two, and then we'll go take a break. Or should we take a break now? Yeah, let's take a break now. Now I'm going to solve problems 1, 2, and 3. After that, you're going to break down into groups, and then you will either present in class if we have time, or you will take a picture of your problem with a solution and post it on Edmodo. So let's start with problem number 1. We only have 2 variables. Who would like to read problem number 1? Okay, Lauren, thank you.
When travelers to students are of the trip on the highway and the rest of the through the city at 40 miles. The 270-mile trip takes in a total of 50 hours. How much of this time is spent on the highway? How much time do you spend?
Okay, so not 50 for 5, right? 5 hours. It's okay. And we have a 270-mile trip. Now, to define our variables, we need to read the question. So, Lauren, read the question. Well, questions again.
How much of this time does he spend on the highway? How much time?
Okay. So the question is how much time driving through on the highway and how much time driving through the city. So we're going to use not X and Y. You can use any letter you want. So we're going to use H for highway. But to define it, I want you guys to write a sentence. So the way we're going to write the sentence for H will be the amount, and I want you to write the whole statement, amount of time spent on the highway. For the city, we're going to use the letter C, and that will be the amount of time driving through the city. Now, to solve a system that has two unknowns or two variables, we need to have at least two equations. One of those equations is going to be given, we're going to use the information given to us. So we know that the total distance of the trip was 270 miles, and we know the total amount of the trip was 5 hours. So one of those equations is going to represent the total time. Now we know that the total time is 5 hours, and the two intervals in which we're going to divide that will be the amount spent on the highway, which we're calling H, plus the amount driving through the city, and that will be C. That is our first one. For our second one, we're going to use the total distance. For the total distance, we're going to do something similar to what we did on the first page of this handout. And that was, let me show you, what we did here. We took into the product of the speed times the time. And that comes from the formula for speed. If we solve for distance, we will get S times T. So we're going to do something like that. We know that the total distance is 270 miles. What is the speed driving through the highway? 60. So 60 times the time driving through the highway. We don't know what the time is, but we know we have a variable for that. So it will be 60H. Plus, what is the speed driving through the city? 40. And the time, we don't know what it is, but we're going to call it C. Now we have a system of a 2 by 2, two equations, two unknowns. It says here that we could use either the inverse method, or augmented matrix. This is the RREF. And the inverse method is when you start like this, you create the equation of the coefficients, the variables, and then the constant terms. And to solve it, you will have to find the variables will equal to the product of the inverse of the coefficients times the constants. So for this problem, I would have used the first method, the inverse method, because I think it's important to review both. So, okay, we create the coefficient matrix, which is going to be, we take the coefficients here, there's a 1 and a 1. And then we take the coefficients of the second equation, 60 and 40. And then that multiplied by the variables, which in this case we have H and C, that should equal to the constant terms, which it is 5 and 270. So to solve it, remember, we need to find the product of the inverse of the coefficient matrix times the constant matrix. So what we could do is enter on our calculator the coefficient matrix, but then you will use that exponent function and enter the -1 so that you actually get the inverse of that, and then you multiply it times the constants, which is 5 and 270. So if we do that, we're going to end up with the product of about 2 by 1. That means 2 rows by 1 column. And those will be the answers for H and for C. So I want you guys to try that out, please. All of you, I'm going to pick one person. You got it, Luis?
No, no, yeah.
So remember, we need to enter this matrix to the -1. That means the inverse.
Do we put the ref first?
No, well, you're thinking about the ref, the reduced row echelon form. That will be the augmented matrix. We'll solve the next problem that way. This is called the inverse method. Let's review a little bit how you will enter that on the calculator. So you need to select a 2 by 2 matrix. And then the coefficients for the first row were 1 and 1. For the second row, is it 60 and 40?
Yes.
Okay. 60 and 40. And so we move to the right side to exit out of the matrix, that we use that symbol. To the -1, you must use the negative below number 3. And then we move to the right, and then times, and now we need a 2 by 1 matrix, 2 rows, 1 column. And we need the coefficients, the constant terms. So that will be 5 and 270, yes? Am I correct? And then we press enter, and we should get that, 7 halves and 3 halves. Now, if we translate that into hours and minutes, we could say that the amount that he spent driving on the highway was 7 halves of hours, or 3.5 hours. The amount of time that he spent driving through the city was 3 halves. If we divide that, we will get 1.5 hours. So let's move to problem number 2. Are we okay with this? Do we have any questions? Okay. Now, who would like to read the next problem? Marco, thank you.
Food encounters some road construction that slows him down. While he is still able to go 60 miles per hour on the highway and 40 miles per hour to the city, he can only go 20 miles per hour past the construction. That is twice the time the construction as because on the highway. So his time, 270-mile rate takes 7.8 hours. How much of this time just spent on the highway in the city is
All right, so now we're talking about 3 different sets. The first one will be the highway. The next one will be the city. And now we have construction. So we cannot use C again, so we're going to use N. And let's go ahead and define our variable. So this will be the amount of time driving on the highway. Letter C will represent the amount of time through the city, driving through the city. And N will represent the amount of time driving through construction. Now for the system, we're going to use the same idea that we did with the previous problem, but now we have 3 variables, 3 unknowns, so we need to have at least 3 equations. The first one is going to represent the total time again. And so for the total time, we need to add our 3 variables, so h plus c plus n is equal, in this case, it is 7.8 hours. Our second equation is going to represent the total distance. And distance, we're going to keep using that formula that says that the distance is the product of the speed times the time. So for the first one, what was the speed driving through the highway? 60. So 60 times the time. We don't know what the time is, but we know it's being represented by the letter H. What was the speed driving through the city? 40, so 40 times C. And what was the speed driving through construction? 20, so 20 times N. And the total distance is the same as the other trip, 270 miles. Now, we do need a third equation. We cannot solve a system of 3 variables with 2 equations only. So, where could that third equation come from? Okay, so, anyone? Luis, I want you to read the second sentence of that problem. Starting on he spent
twice the time passing the construction as he did on the highway.
Okay, so twice the time passing through the construction as he did on the highway. So what that means is we're going to compare the speed of the highway with the speed of the construction. So if you notice, his speed was 40 miles per hour driving through the city, and it was 20 miles driving through the construction. And I'm going to be honest with you, this is a little difficult for me to explain because sometimes I think that it is the opposite of what I'm going to tell you. So, but once we get the answer, you will see it makes sense. So the amount of time that he spent driving through the construction was equal to twice the amount of time that he spent driving through the city. Not the city, I'm sorry, the highway. You take it back. So 2 times H. All right, and we know that to put the graph in a matrix, we need to have it in standard form or with all the variables on the left side. So what I need to do is take this 2h to the left side. We know the 2h is positive. In other words, it's adding to the n. So if we move it across, what's going to happen with it? Negative. So negative 2h plus n equals what? We don't have anything else left on the right side. So what does that equal to? 0. So now we're going to solve the system by the Gauss-Jordan or reduced row echelon form. So what will be the coefficients of the first row? 1, 1, 1, 1, 1, 1. Okay, very good. 1, 1, 1, 7.8. Okay, second row.
60, 40, 20, 1, 7, 270.
270. What does that line represent?
Equals.
The equal sign, very nice. Okay, what about the third row? And I want to point something out. We need to keep a certain order. So the first column represents the coefficients of H. The first column, H. The second column represents the coefficients of C, driving through the city. And the third column represents driving through construction, letter N. So if we look at our third equation, that one does not have C. So what will be the coefficient for H? No. Negative 2 for H. Now for C, it is 0. And for N, 1. And what will be our constant term here? 0. Okay. So now let's go ahead and solve this with the Gauss-Jordan method or reduced row echelon form. So let's go to matrix. Select number 5. And we need to, what are the dimensions of the matrix that we need? We need to account the last column. So 3 by 4. So go ahead and enter your matrix, please. So remember, first row was 1, 1, 1. 7.8, thank you.
60, 40, 20, 70, -2.
And remember, you must use this negative, the one below number 3. Negative 2.
0, 1, 0.
Yeah, and then we get 2.1, 1.5, and 4.2. Those are our solutions.
I forgot to put ref.
Oh. Remember, it's not ref, it is row reduced echelon form. Or reduced row echelon form. Now, remember how I told you that sometimes this doesn't make a lot of sense to me, right? Because the statement said he spends twice the time passing the construction as he does on the highway. So sometimes I'm inclined to think that it should be H equals 2N. But if you think about it, it says twice the time as he does on the highway. So maybe the sentence is not worded very good, but twice the time on the highway, 2 times the amount on the highway is equal to the amount of time driving through construction. Now, if we look at our answer, our final answer, we see here that the amount he spent driving through the construction zone was 4.2 hours. And the amount of time that he spent driving through the highway was 2.1 hours. So it kind of makes sense that the amount driving through construction is 2 times the amount of time driving through the highway. All right? Now I'm going to do one last problem, and then you will be working on your own. So next one, and it's only 2 unknowns. So who would like to read it? Natalie, thank you.
Chemicals demonstrate that the certain acid is starting to different dosage. The while came to that is all because the acid goes out of the starch, which is 2% acid. It is this for some for each container to make 60 milliliters of 6% acid. How much from each container should be used?
All right, that was fast. So let's see. We have 2 types of solution. Now, Natalie, could you please read the question again?
How much from each container should be used?
How much? So that's what's going to define our variables. We have 2 solutions. One that is called the weaker solution, so let's use W. And the other one is called the stronger solution, so we're going to use X. So for the weaker solution, we're going to use, we're going to define it as the amount of weaker solution. S will be the amount of stronger solution. Okay, and we're gonna refer back to that page, the first page, where we talk about the hydrogen peroxide. And if you notice, the total amount of hydrogen peroxide, we had to multiply the amount of the solution times the concentration. So let's see if we could do that. Now, we know that the solution is going to be, the total amount of liquid is going to come from here. So to determine that, and that is the whole thing, the acid mixed with whatever they're mixing it. So we know that the amount of the weaker solution plus the amount of the stronger solution has to equal a total of 60 milliliters. The second equation is going to talk about the concentration, how much acid is in that solution. And we know one thing, the concentration, they want it to be 50% acid. So if the total amount of the liquid is 60 milliliters and 50% will be acid, what will be the total amount of acid? Someone said 30? Yes? Correct. Total amount of acid. And so that will be 50% of 60 milliliters. So because of that, we're going to make our second equation equal to 30 milliliters. Now the concentration is going to be the following. The amount of the weaker solution times the concentration of it, and that is 25%, so I'm going to use 0.25. For the stronger solution, it's going to be S times the concentration of that, and that is 65%. As a decimal will be 0.65. Now, I want us to solve this system by using the inverse method. And remember for that one, because we need to review both. We need the coefficients first, and that will be 1, 0.25, 0.65. Our variables are W and S, and that is equal to the constant terms, which are 60 and 30. To solve our system, we're going to need to do the following. We need the inverse of the coefficient matrix, times the constant terms, and that will give us our solution, W and S. Right, so do we have a solution, guys? So you should get for your solution a 2 by 1 matrix. Okay, I'm going to pick one person randomly. So remember, you need to enter this matrix 1, 1, 0.25, 0.65. Use the inverse. So you use that exponent to the -1, and then you multiply it times 16 times 30. Okay, what do you get, Andrew?
17.42 and 42.2.
17?
Oh wait, no.
No. Okay.
I got 22.5 volts.
22.5 and 37.5. Now we could check, let's see, if we add 22.5 plus 37.5, how many milliliters do we get?
A lot.
60. Yeah, and that's what we wanted, right? So yes, we're gonna say that the amount of the weaker solution will be 22.5 milliliters, and the amount of the stronger solution will be 37.5 milliliters. So this concludes the video. Now what I want you to do is get into groups, and then I will assign a problem to you. Or in the case of 5th period and 6th period, Ms. Bone will assign a problem to you. So thank you for watching.